Let me derive the last one. The last one is very interesting. We want final velocity square equal to initial velocity square plus 2x. This equation I am interested. To obtain final velocity square equal to initial velocity square plus 2 times x, or final velocity square equal to initial velocity square plus 2 times a x minus x naught. Both are one and the same. We know that acceleration equal to rate of change of velocity. So this equation can be rewritten as dv upon dx, because I need to include x. So into dx upon dt. This and this are one and the same. Look at this relation. It is dv by dt. You have dv by dt. Dx gets nullified. No issue. Now, can I take this dx upon dt as velocity? So it becomes velocity. This is velocity dv by dx. This first part is as it is, dv by dx. The second part, dx upon dt, is velocity, because velocity equal to dx upon dt. I hope you understand. Now this equation gives me, when I look at this relation, it is a dx, because this dx is denominator, it multiplies with the a dx equal to v dv. So it is x variable, it is v variable. So integrate it now, call it as equation 2. Integrating. When you integrate this whole equation 2, integrating equation 2. So here I will be getting a step. This integration of a dx is equal to integration of v dv. The limits are x naught, x. The limits are, it's a velocity, initial velocity and a final velocity. Now when I go for the integration, the steps comes like this. A is a constant, take it outside. A is a constant, take it outside. And lower limit x0, x. It is a dx. You write it dx, which is equal to v is, both are variable. You can write it as integration of v dv. Gives you very simple rule. Let me write it once again. Initial velocity, final velocity, v dv. This relation gives you a very meaningful, look at this relation, a. This gives you x, lower limit, upper limit, then is equal to, it becomes v square by 2, lower limit, upper limit. So I hope you remember, a is constant, a is a same thing written, a is outside, a is outside. Integration of dx gives you x, lower limit, upper limit. So since it is v dv, so integration of this v dv gives you v square upon 2, lower limit, upper limit. So once I simplify the steps, it becomes a, it becomes x minus x naught. On the right hand side, you have 1 by 2 outside. Take 1 by 2 out, it becomes v square, final velocity square minus initial velocity square. This v is replaced by v square because it is a square. Hence simplification gives you 2 come this side. It is 2a x minus x naught. On the right hand side, you have v square minus v0 square. Finally, this equation is obtained. Final velocity square equal to initial velocity square plus 2ax, or final velocity square equal to v0 square plus 2ax. This minus v0 is brought to left side. This equation can be written as v square equal to v0 square plus 2 times a x minus x naught. You can cross check. Any other doubt, you can bring it to my notice. I'll just correct it. This completes the final derivation. Final velocity square equal to initial velocity square plus 2a x minus x naught. the three equations of motion which you obtain: final velocity equal to initial velocity plus at, then displacement equal to x0 plus v0 t plus half at square, and of course the more meaningful final velocity square equal to initial velocity plus 2x. So what is free fall motion? Whenever an object falls under gravity, under the influence of gravity, it is going to acquire constant acceleration, but its velocity is changing with respect to time. And that free fall motion is called acceleration is constant, uniform acceleration. That acceleration happens to be g. G is going to be 9.8 meter per second square. And this g is called acceleration due to gravity. And upward positive y, this is negative y. Here, since it is always downward g, so we take it as acceleration due to gravity equal to minus g equal to minus 9.8 meter per second square. Yes. Now, when an object falls under free fall, when an object falls under free fall means air resistance neglected. Air resistance neglected. Such motions are called free fall motions. There is no opposition. Air resistance neglected. So what are the equations of motion? This equation, because your initial position, you are going to release it. Consider your initial position is y0 equal to 0, and final position y equal to y, and initial velocity v0 equal to 0, final velocity equal to v. Then the equations of motion, v equal to v0 plus at. Final velocity is v, initial velocity is 0, acceleration is negative, so it becomes minus g t. This simplifies to minus 9.8 t. Final velocity indicates, minus indicates it's a downward direction, 9.8 into t. 1 second, 9.8, 2 second. If I say t equal to 1 second, velocity equal to minus 9.8 into 1 second, it becomes minus 9.8. Then if I say t equal to 2 second, your velocity equal to 9.8 into 2, roughly close to 20 second, minus 20 second, in that fashion. Now similarly, what happens my acceleration equation? Next equation, as I said, this, you do remember x equal to y, x naught equal to y naught. So in that way, I'll be writing y equal to y0 plus v0t plus half at square. This equation simplifies to, it becomes 0, y. This becomes plus, again like 0. It becomes minus 1 by 2, 9.8 t square. And finally, I can say y equal to minus 9.8 divided by 2, 9.8 divided by 2 t square. And this can be written as minus, you can have 2 4 and you have 4.9 t square. This is the equation. Now, if you substitute the values, you'll get some equation. The corresponding velocity equation is minus 9.8 and your position equation is y equal to minus 4.9 t square. This is a relation. This is velocity versus time. This is position versus time. You can have a relationship. Okay, let me draw the graph, corresponding graphs. You have an equation. The reduced equations are v equal to minus 9.8 t and your y equal to minus 4.9 t square, and similarly final velocity square equal to you have an initial velocity, it is v0 square plus 2ax. So I can write it as 0, it becomes minus 2, it is acceleration is 9.8, it becomes y. So you have a relation between this. Finally, it becomes minus 9, something like 9 to 10, it becomes 19.6 y. This is v square. So all the three relations, you can call it as 1, you can call it as 2, you can call it as 3. The corresponding graphs looks like this. This is first a graph which is written for acceleration. So let me take acceleration, it is a negative. This is time, this is acceleration which is downwards, it is 0, 5, 10. So I'll be having acceleration here. So this corresponds 10 meter per second, this corresponds 5 meter per second, this corresponds a equal to minus g equal to minus 9.8 meter per second square. This is time, whether it's a 1 second, 2 second, or a 3 second, this remains a constant. Yes, this is the first graph, it is called AT graph, A versus T graph. Next, we'll have one more graph, which I'll be calling it as let me draw both the graphs here. Yes, this is again time axis, and this is again, you can write it as velocity. Velocity versus time, it is just, yes, this is going to be constant slope. So you can take a slope, this is called a slope, slope equal to a constant, this constant is a equal to a constant, and where a equal to minus g. So you can have 1 second, 2 second, 3 second, 4 second, 5 second. You can put it here. Now this is called velocity versus time. The last graph which we are interested is a position time graph. This is again time, this is again y. So here it is positive, here it is negative, minus, I have a relationship, minus 10, minus 20, like that. You have values, 1 second, 2 second, 3 second, 4 second, 5 second. The curve looks like this. This curve is going to be like this. So where I had a graph, AT graph, I had VT graph, and this graph is my y versus t. This is position time graph, this is velocity time graph, this is acceleration time graphs for free fall motion, where acceleration is a equal to constant, which is equal to minus g, which is equal to minus 9.8 meter per second square.